Hello everyone, my name is Suresh. I'm a software engineer here at Outshift by Cisco. Today I'll demo Quantum Alert, one of our quantum applications for classical use cases. Let me share my screen. Alright, so let me get into Quantum Alert. Okay, as Enith explained, the main objective of this concept is to identify the eavesdropper in the channel while transmitting classical data using techniques. This demonstration will run on a real hardware setup in our Cisco lab located in Santa Monica. Okay, let's take a look at the diagram. This is a block diagram, illustrates the experimental setup in our lab. Let's touch base on some of the major components. And for reference, we have attached pictures of each hardware device from our lab. Okay, here is the user A and user B. User A represents Alice and B represents Bob. And A sends classical data packets to user B. And so we have utilized a Cisco optical transceiver to send the data packets, and as well as other end, Bob receives from the classical receiver. These are very sensitive receivers. These can detect low power signals but are unable to identify eavesdropper. The next component is Cisco entanglement source. So it generates entanglement pairs as signal and idler at different wavelengths. The source is optimized to identify the uh, optimal resonance frequency, producing entanglement pairs at the desired ITU channel with the highest pair rate. The next device, the major component is quantum detector. Uh, the bottom portion, the cylindrical yeah, uh, device is our detector, and top one is the time tagger. Detector basically detects the quantum photons, and the top one is the time tagger. Detector sends a signal upon photon detection, then time tagger captures the time of photon detection on both user A and user B side. So as you notice, we have time tagger 1 located at user A location and time tagger 2 located at user B location. So yeah, as Init mentioned, we use coincidence measurement between time tagger 1 and time tagger 2. So coincidence measurement refers to the number of entangled pairs detected and measured simultaneously at detector 1 and 2. So this is one of the core measurement to identify the existence of an eavesdropper through the optical link. And also we have an emulator set up here to represent eavesdropper. Uh, this is optical coupler with 1% tapping. All these components are controlled by our quantum controller software sitting on top of this setup. It issues commands to each hardware agents and hardware devices and help orchestrating multiple steps to run this experiment job. Let's move on to the bottom portion. We Here are a few configuration parameters that we can set up before running the job. Uh, so yeah, the first field is coincidence threshold. As we talked earlier, coincidence measurement, this coincidence range varies due to multiple factors and settings. So we optimize the source and other factors such as resonance, temperature, etc., to establish a perfect link for our baseline. So we need to capture the coincidence threshold value for a given time range with the baseline measurements. For example, if I choose coincidence threshold as 90%, that means anything falls below the 90% threshold, I want to get alerted. That means there is something going on in the channel. It indicates some issues such as an eavesdropper in the channel. The next parameter is number of failures. You can choose number of failures. Let's say we capture coincidence measurement every second. So, and this field determines how soon we need to get alerted and say how many points fall below the threshold line. And the last one is the time window. So it defines the time window to consider for capturing average coincidence rate and define the threshold value. Okay, all right. So before clicking on this job, starting the quantum alert demo, what happens when I click this button? So in the behind the scenes, our quantum it submits a job request to our quantum controller, and controller starts issue commands to our hardware devices, and one of the major it has four endpoints, four components it will be communicating. Cisco entanglement source, it starts generating entanglement pairs. Then classical transmitter starts sending classical data packets, and other end time tagger 1 and time tagger 2 they start collecting the photon detection timestamps. And also intermediately I will manually enable this eavesdropper. So we manually introduce eavesdropper in the channel and notice how the coincidence measurement impacts. All right. Also, as I mentioned, coincidence measurement is one of the measurement we track, and also in the classical data, packet error rate, also we capture and monitor. Okay, let's run the demo. So as I mentioned, I set 90% coincidence threshold based on my baseline metrics. It defined dynamically generated 5,300 pairs right now. So this is my baseline measurement, and the dotted line you can see it's the my threshold percentage, and the below graph represents the classical data, the packet error rate between user A and user B. Right now, everything goes fine. There is no eavesdropper in the channel, and coincidence rate is pretty consistent given the classical data. Let's see for a few seconds, then I will start introducing our eavesdropper in the channel. It's a coupler with 1% tapping. So, okay, let me introduce eavesdropper. As you see, as soon as I introduce 1% tapping with our emulator setup, coincidence percentage started falling off, and I chose 10 points. If 10 points falls below the threshold, I need to get alerted. So as you see, I already got alerted. For demonstration purpose, I'm letting it run for a few more seconds, but in reality, this is where user A else needs to stop sending data and take precautious measurement what's going on in the channel. But it clearly indicates there is a eavesdropper in the channel. Okay, now let me remove the eavesdropper from the channel and see how this coincidence measurement impacts again. As you see, again, it goes back to my baseline measurements and goes consistently. And if you notice the classical error rate, there is no difference, even with eavesdropper in the channel or without eavesdropper in the channel. That's where quantum comes to rescue and identify eavesdropper in the channel. Yeah, that's pretty much I have for this demo. Thank you so much for listening in.